Hey guys, Zong here, back in another math video. My video editing software was bugging up last week, so I couldn't do the video. So this week we're going to be doing question number 1 from Daniel's USAMO practice test that he made. And take a look at the problem, pause the video if you need to, and we'll go over the solution shortly. So the first thing you want to do with this sequence is move all of these terms to the left side and put them between the terms they're made of. So for example, minus x1 x2 plus x2 squared minus x2 x3 plus x3 squared minus x3 x4, and so on, is greater than or equal to n plus 1 over 2. Now what you do is multiply both sides by 2. And I know I have to write all this out, but it'll be useful. Okay. Now, the way you simplify the left side is by splitting up, sorry for those marks, my tablet is bugging out, is by splitting up these terms so that they form something like this. 2ab plus b squared. And you can do it by splitting it up like this. x1 squared plus x1 squared minus 2x1 x2 plus x2 squared plus x2 squared minus 2x2 x3 plus x3 squared plus x3 squared. And if you do this, you'll see that they go by these sort of sets, and these sort of simplify down, plus x4 squared, and these sort of simplify down to x1 squared plus x1 minus x2 squared plus x2 minus x3 squared plus x3 minus x4 squared, and so on. So, screwed up the last one. Okay, eraser tool isn't working, and so on. So, what you can do from here, and remember sorry, my tablet is lagging very badly, n plus 1, ignore this thing, since we multiply both sides by 2. And, oh yeah, at the end of, I don't know why my tablet is doing this, at the end of that, you actually have an extra xn squared. Because the last xn squared is not paired with anything after it, so you have one left over, just like you have one x1 squared left over on the left side. And since we know that x1 is equal to 1 and xn is equal to n, you have 1 plus n plus, and then this thing again, blah blah blah, is greater than or equal to n plus 1, or n squared plus n. Oh, sorry, 1 plus n squared, since I forgot it's xn squared. And then if you subtract 1 and n squared from both sides, you get blah blah blah, that thing in the middle is greater than or equal to n minus 1. So what do you do from here? And let me rewrite it, because I know there's a bunch of scribbles all over the place, because my tablet is being very uncooperative. x3 minus x4 dot 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 is greater than or equal to n minus 1. And this is what we are left with, and from here is where it gets a bit tricky. Now, before I made a few, okay, my tablet is really sort of annoying me right now, but before, if you remember, we made a bunch of videos on the Cauchy-Schwarz inequality, and what the Cauchy-Schwarz inequality basically says is that if you have a1 plus a2 plus a3, all of these squared, terms all squared, dot dot dot, multiplied by b1 squared plus b2 squared plus b3 squared, dot dot dot, that's going to be, let me think, that's going to be greater than or equal to a1 b1 plus a2 b2 plus squared. So what does this do for us exactly? Well, we do have 1/2 of this equation on the left. For instance, we have x minus 1, x minus 2 squared plus x2 minus x3 squared, etc. So we have like this part, but we don't exactly have this part to work with yet. So what do? What we can assume is that we can make up our own equation for this. We can just assume every single b is equal to 1 and multiply both sides by the sequence of b. So if all the b's are equal to 1 and we multiply both sides of this expression by a sequence of 1s, we get x1 minus x2 squared plus x2 minus x3 squared multiplied by, for each term, 1 plus 1 plus 1 plus 1, which is equivalent to the b's. And what's that greater than or equal to? Well, this is just a1 b1 plus a2 b2, and since b is equal to 1, that's just going to be a1 plus a2 plus a3 squared. And since we know that a in this case is just x1 minus x2, this is a1, a2. Since we know these are our a's, we just add them together. And what happens when you add them together? Well, they cancel out really nicely. So you get x1 minus x2 squared times a bunch of 1s. For each term for each a in here, there's a 1 in here, is greater than or equal to x1 minus x2 plus x2 minus x3 plus x3, and guess what? It all cancels out very nicely, and you really just get x1 minus xn squared. And I'm sort of running out of space, so let's just move some stuff to over here. Let's move up here. Now, how many 1s are in here? How many terms are there exactly? Well, it goes from x1 to, let's see, the last term is x to the n minus 1 minus xn, right? Since it goes from x1 to xn minus 1, I mean, there should be n minus 1 terms in here. So this should have n minus 1 terms. And because of that, what's n minus 1 ones added together? Well, that's just n minus 1. So because of this, you get x1 minus x2 squared this thing multiplied by n minus 1 is equal to, and of course x1 minus xn squared, actually sorry, I think actually no, yeah, that's correct, okay, x1 minus xn squared, of course, is just 1 minus n squared, which is also equal to n minus 1 squared, because, you know, squaring just takes away the negative 1. So if you divide both sides by n minus 1, you get x1 minus x2 squared plus x2 minus x3 squared all the way to xn minus 1 minus xn squared is going to be greater than or equal to n minus 1. And that's just this expression. That's the expression we proved earlier. That's just this expression. And since we just proved this expression, and since this expression is equivalent to the original expression which we proved before, we have proved this inequality. So thanks for watching.